Hi everybody. In this video we're going to talk about functions. Functions are incredibly important in mathematics. Let's just take a look at some examples before we get rolling here. Okay, so here's an example of a function that was developed to predict stock prices. So this function will help us determine whether a stock might go up or down. Some functions have been used to predict the rate of infection of the COVID infections. Right? Functions can be used to model the propagation of waves. So these is if you perturbed something and you're watching the ripples of the waves propagate through that something. So the functions would be things that are modeling this. Functions can produce beautiful, beautiful pictures if we look at their graphs or some other kinds of pictures relating to them. And this is a famous graph called the Mandelbrot set. Maybe I shouldn't call it a graph per se. It's a plot relating to a very simple function. You can read about it. Just look at the Wikipedia page for Mandelbrot set. So functions, there's all kinds. They're very useful in mathematics. Let's talk about what they are. Okay, so functions are ways of assigning an output to inputs. Okay, so you're going to take an input, the function is going to do something to it and transform it and spit out an output. Okay, so it's going to take an input and spit out an output. And the important thing to remember here is that to each input, a function assigns a single definite output. And that word single, we're going to see, is very important. Okay? Let me give you just a straightforward example of something you've probably experienced in your life, a function, and that is a candy machine. A candy machine can be thought of as a function. When you type a code into the candy machine and put your money in, the machine will spit out a candy bar. So the machine has processed the code and has assigned to that a candy bar, and that's a function. The relationship that assigns to a code a candy bar. Okay, so this would be an example of a function. So our first example, the code that you type into the machine and the candy that you get out. That's a function because to every input, there is a single definite output, right? The code corresponds to a single candy bar. So if I type in the code 1034, that might be associated with Snickers, right? And if I type the code 1035, that might be associated with Twix. Okay. Now, something else could happen. I could type in another code. Maybe there's a code 2939, and that is also associated with Twix. That's okay. Two inputs can give you the same output. If there just happened to be two codes that gave you the same candy bar, that's fine. It's still satisfying this rule that to each input, there's a single output. I know, given the code, exactly what I'm going to get out. The machine knows this. The machine is the function. Okay? And let's look at another example. What if I tried something like this? I want to know I want to take the cost, and I want to associate that with the candy. So maybe $1.25 is associated with a Snickers. But $1.25 will also give me a Twix. Now look what's happened here. I have an input. Is it associated with a single output? Nope. Nope, there's not one single definite output associated with this input. So this would be an example of something that's not a function. That's not a function because this input is not associated with a single output. It's associated with two outputs. So for a function to work, I need to know that from what I put in, I need to know exactly the single thing that I'm going to get out. And that's not the case here. So this is a function. This is not a function. Okay, this one is okay. This is a function. But this one is not. Okay. Now, if I reversed this, I'd be okay. All right. If I said candy and I tried to associate with that the cost, well, Snickers, oops, is associated with $1.25, and Twix is associated with $1.25. That's okay. I may have other candies in here like Doritos. Maybe they're associated with something else, maybe $1.75. Okay. But the fact that these two come together, is that a problem? No, that's not a problem. As long as each candy, wait for this party to go by. Okay, as long as each candy is associated with a definite number on the other side, in this case it's a number, it doesn't have to be a number every time, but as long as it's associated with a single definite output, it's a function. Okay, so this is a function. So it's a transformation, taking one thing, producing another one. But we just have to make sure that that doesn't happen, that the single input doesn't go to two different outputs. Okay, so that's what functions are. We have names for the things that we plug into the function and things that come out of the function. The set of all things that we can plug in, that's called the domain. So the domain is all possible inputs. That's the domain. The range is all possible outputs. Okay, so the domain are the set of, in this function, is a set of candy bars in the machine, and the range is the set of all costs of candy bars in the machine. If we go up to example 2, doesn't make sense to talk about the domain and range because it's not a function. Let's go up to example 3. What would the domain and range be here? Well, the domain would be the set of all codes, and the range would be the set of all candy bars that are in the machine. So domain is the inputs, range are the outputs. Okay, let's look at some mathematical functions. So in mathematics, a lot of the functions, not all of them, there's plenty that don't do this, but a lot of the functions have formulas associated with them. Okay, so let's take a look at some of these. Let's take a look at my notes here. Okay, so let's take a look at this guy. So I'm going to describe the function by writing down what it does. It takes a number x, and the output that it assigns to x is x squared. So I've given you a formula for how to transform. Oh, I didn't have my mic on. I hope that wasn't too bad. How to transform one number into another, right? So if I plug 1 into this function, my output is going to be 1 squared, which is 1. If I plug 2 into this function, my output's going to be 2 squared, that's 4. 3 becomes 9. Negative 5 becomes 25. And I could keep going with this. I could write down lots of things and compute their squares. So we could kind of describe how a function works by writing down a table. Now, the question is here, what is the domain and what is the range of this function? So I'll just, to abbreviate, I'll write DOM and RAN, but we know that this means domain and range. Well, the domain is the set of all possible inputs that I can put in over here. So what are all possible inputs that I can plug into a function, into this function? What are the numbers that I'm allowed to square? And the answer is any number. In this class, we're going to say all real numbers. And that is because later in the class, we're going to talk about numbers that aren't real numbers. They're called complex numbers. But for now, we're not going to worry about complex numbers. But what we'll write here is all real. I'll abbreviate numbers to save space. It's just a pound sign. So all real numbers. Okay? Now there's another way to write this. Instead of writing all real numbers, I could use an interval. I could say this. So that's the interval from negative infinity to infinity. That's all numbers between negative infinity and infinity. That's all real numbers. Another way to write this would be to use what they call set builder notation. Okay? So it's to write a set, we use these curly braces. Okay, so I'm going to write the set of all things, which I'm going to call x, such that, this symbol means such that, okay, all numbers x such that x is between negative infinity and positive infinity. So all numbers x such that x is between negative infinity and positive infinity. These are three different ways of writing the same thing. So you should be able to give your answer in any one of these formats. Now, what's the range? What numbers can I get out of this function? Well, here we have to be a little bit careful, right? If I'm squaring things, can I ever get a negative number? Not if you're plugging in real numbers for x. You always get a non-negative thing out. So this is all non-negative numbers. Now, how could I write that as an interval? Well, all non-negative numbers go from 0 to infinity. Could include 0, so I'm using a square bracket. Or using set builder notation, I would write the set of all x such that x is between 0 and infinity. So here we have our domain and our range, and we've written them three different ways. Okay? So that's the squaring function. That's how that one works. Let's take a look at another one. Let's take a look at the function that takes x and produces square root of x plus 3. Okay? What would a table of values look like? Well, my inputs, I could plug in 0. I would take the square root of 0 plus 3. That's just 3. 1, square root of 1 plus 3. That's 4. I could put 4 in here. Square root of 4 is 2, plus 3 is 5. What if I tried negative 1? Uh-oh. Can't take the square root of a negative number. Right? So, no answer here. So not every input has an output. So there's some things that aren't in our domain. So we can already see our domain's not going to be all real numbers because there are some numbers that don't work. Okay? So what would the domain be? And what would the range be? The domain, what numbers, we can see that some don't work. So which ones do? Well, what was the problem with this? It was negative. That's what made it not work. As long as I don't have a negative number, I can take the square root of it. So the domain is all non-negative numbers. How would I write that as an interval? Well, I could write 0 to infinity. How would I write that as an inequality, using the set builder notation? Set of all x such that x is between 0 and infinity. So these are three different ways of writing down the same thing, and you should be prepared to write it in any one of those formats. What about the range? What are my possible outputs? Well, what is the smallest number I can get out of this? Well, the smallest number happens when x is 0. That's as small as this can get. And so therefore that's as small as this can get. And how small is that? It's 3. So the smallest the numbers in the range can be is 3. How big can they get? Well, I can make this as big as I want just by plugging in bigger numbers for x, and then adding 3 just makes them even bigger. So it can go all the way up to infinity. So this is all numbers 3 or greater. How do I write that as an interval? Like that. How do I write it in set builder notation? All x such that x is between 3 and infinity, including 3. And again, you don't have to write down all 3 of these. You just have to be able to write down any one of them, right? And you should be prepared to put it in any format. Okay, let's look at another one. X goes to 1 over x minus 1 squared. So for instance, if I plugged 0 into this function, what would I get? Well, I get 1 over negative 1 squared, that's 1. If I plug 2 into this function, what do I get? 1 over 2 minus 1 squared. Well, that's also 1. If I plug 3 into this function, what do I get? 3 minus 1 is 2, squared is 4. That's 1/4. What if I plug 1 into this function? 1 over 1 minus 1, that's 0 squared is 0. 1 divided by 0 is not defined, can't divide by 0. So you can see there are some things that aren't in the domain, right? This does not have an output, so this is not in the domain. Okay, so what is the domain and what is the range? Let's think about this. Are there any other numbers that I can't get an output from? Well, if you think about it, no. The only time this can have a difficulty is when the only trouble spot is 0, right? When I'm dividing by 0. Any other number down here, I'm fine. I can divide 1 by anything else as long as it's not 0. So all I really have to be worried about is when this is 0. Okay? The only time it's 0 is when it's 1. So the domain is everything except 1. So this is all real numbers except 1. How do I write that in interval notation? Well, okay, so I can go from negative infinity up to 1, but I can't include 1. And then I can go from 1 to infinity. So I've jumped over 1 because I've used round brackets to indicate that 1's not included in either of these intervals. So that's how you'd write it in interval notation, using the union symbol. In set builder notation, it's the set of all x. This is actually easier to write this way. X is not equal to 1. I think set builder notation is the easiest way to write this one. Right. What is the range? Well, let's see. How small can this be? Can I ever get negative numbers out? Well, no, because I'm squaring it. I'm dividing 1 by something squared, and squared is always going to make it non-negative, so I can't get a negative number. So I know negative numbers are not in the range. Can I get 0? Well, I think about it. How could this ever give me 0? I'm dividing 1 by a non-negative number. Can you ever divide something by something, a non-zero number by something and get 0? No. So 0 is not in the range. Can I get small numbers? Well, I can get 1/4. Can I make that smaller? Yeah, I could get something smaller than 1/4. I just have to plug in something bigger for x. Plug in 101 for x. 101 minus 1 is 100. 100 squared is 10,000. It's 1/10,000th. I can get this to be very tiny, as tiny as I want, in fact, just by choosing a very large number for x. So the range can get very close to 0. So this ends up being all positive numbers. why can it be very big? I mean, we explained why it can be very small. Just plug in a big number for x. How could I get this to be very large? Well, if I wanted to get that to be very large, let's try plugging in a number like 1.001. 1.001 minus 1 is 0.001. 0.001 squared is 0.00001. Teeny tiny number, right? But what's 1 divided by 0.00001? That's 1 with 4 zeros after it. That's huge, right? Maybe that's actually one more zero. Let's see. Yeah, 1, 2, 3, 4, 5. I should have 5 zeros, sorry. It's 100,000, right? So this is a very big number. I can get this number to be, I can get the outputs to be very big just by taking this very close to 1. So that's why I can get all positive numbers. I can go all the way up to infinity just by making this really close to 1. Okay, so all positive numbers, I can write that as the interval from 0 to infinity, not including 0. Or in set builder notation, set of all x such that x is greater than 0. So these are examples of functions. Okay, and it's important that we be able to identify their domain and range. It's important to identify their domain especially. If you had to focus on one of these, focus on domain, because it's very important to know what you can plug into a function. If you don't know what you can plug into a function, then you might start plugging in the wrong stuff, and then you run into all kinds of trouble. So it's very important to think about, whenever you're given a function, what is its domain? We need to know what's admissible to plug into the function. If I was coding a computer program, that's incredibly important because I need to let the computer know what numbers it can use. If I don't tell it what the domain is, you know what's going to happen? I'm probably going to get an error because the computer is going to go, well, I can plug anything in here, and it'll spit out an error, and then your computer program breaks, right? So you need to know what that domain is so you can keep the program from erroring, right? And of course, even if you're not doing a computer program, it's important to let people know what the domain is so they know what numbers they can use. Anyway, that's this video. I'll see you in the next one.